Okay, I'm going to demonstrate my frequency generator and oscilloscope project for Engineering 267. The oscilloscope and signal generator are combined into one program. Here you can see the signal generator. You'll get a readout of the maximum voltage, the peak to peak volts, the minimum voltage, the mean voltage, a DC value of the voltage, the amplitude, the RMS value of the voltage, the frequency, the averaging type, and the period of the wave. There's a button for write to file to save the data to a file. And then down here we have the controls. We have frequency, offset, amplitude, noise level, and intensity. We also have a frequency multiplier down here, which will multiply the frequency by whatever is read on the dial. We have an amplitude multiplier, which will multiply whatever is read on the dial value of the amplitude. We have a new noise type. You can select uniform or Gaussian. And then as far as a waveform, you can select sine, sawtooth, triangle, or square. Okay, so we'll go ahead and run this. Okay, we're running it right now. Right now we're at frequency multiplier of 100. We're at 1 here, so we're at a value of 100 hertz. Okay, and then here we have the DC offset. So right now we're at 100 hertz. We have the DC offset. We'll move the screen up and down. We have the amplitude of the waveform. We'll go from 0 to 10. And then the noise level of, right now we're on uniform noise. Noise level increasing from 0 to 10. And then Gaussian noise increasing from 0 to 10. And the intensity of the display beam is from a level of 0 to 5. I'm cycling through the frequency multiplier. So this is 10 hertz, this is 1 hertz, 0.1 hertz, and 1000 hertz. 100 hertz, and then back to 10 hertz. Okay, we'll go back to 100. And the amplitude multiplier. So right now we're at 10 on the knob, so this is an amplitude of 10 volts. This would be an amplitude of 1 volt, 0.01 volts, or no, a tenth of a volt, sorry, and a hundredth of a volt, thousandth of a volt, and 100 volts, and then 100 volts, and back to 10 volts. Now you also have 2 cursors which you can select. Moving the cursors, you can make measurements this way. And then here's a button to write to file. If you click on that, you'll be asked to save the data. The program will save the data until you click again to deselect that. So it just saves the data for that period of time. Okay, here we have the oscilloscope portion. So this is just displaying the output of the frequency generator. So here's the waveform. Down here we have a dial for milliseconds per division. Right now we're at 10 milliseconds per division. You can cycle through anywhere from 50 milliseconds per division to 0.1 milliseconds per division. And then also you can cycle through digitally if you like. Over here we have volts per division. We can go anywhere from 5 millivolts to 5 volts per division. Right now we're on 5 volts per division. We can cycle through all the way to 0.1 or 5 millivolts per division. Now the computer is running a little slow. We're using 100,000 samples per second, so it takes a little bit of time. Okay, right now we have the trigger on, so we can get a good display. If we turn the trigger off, you can see that displays kind of jerks around. Okay, so we'll keep the keep the trigger on. Here we have another intensity knob for the intensity of the beam. And then right here we have a vertical control for a vertical display, giving us adjustments are of 0 to 5 volts or 0 to negative 5 volts. And then there's a reset button for that. Then also over here, I don't know why it's doing that. Anyways, over here, okay, it's settling down now. Over here we have a write to file button, and this will write a data file of the oscilloscope, just similar to the writing to file for the function generator. So it'll write to file for as long as you keep it lit. If you click off the button, the writing to file stops. Okay, now two more features I didn't talk about. We also have a frequency graph, graphs of amplitude versus frequency, one for the signal generator, and then also one for the oscilloscope. And you can see this move. If you move the frequency knobs, anyways, this should change the location of the peak frequency. And then we have a stop button. Okay, that's about it. Thanks very much.